Hello everyone, this is a continuation on the solution on the hydrogen atom. So we said that we will be using spherical coordinates and we will be using a Coulombic potential. So our Laplacian in spherical coordinates is given by 1 over r square partial derivative of r square and another partial derivative plus 1 over r square sine of theta sine theta and last term is 1 over r square sine squared theta second derivative with respect to phi. Okay, so we will be acting the Laplacian on our wave function. Now, our Coulombic potential is given by now we will say that it is only a function of r. It is given by minus e square over 4 pi epsilon naught 1 over r. Okay, so by using spherical coordinates, we are able to reduce the effect of the angular quantities in our potential. So the potential is only affected by its radius from the origin. Okay, so just like what we did in the particle in a three-dimensional infinite potential, we will be solving this differential equation using separation of variables. So we would assume now a wave function with respect to r, theta, and phi to have a solution which has a radial part and an angular part. So this is our radial part and our angular part. Okay, so let's write our Schrödinger equation now with the Laplacian acting on our wave function. So we have minus h bar squared over 2m d psi dr plus 1 over r square sine of theta partial with respect to theta next line plus 1 over r square sine squared theta partial square psi partial phi square. So this is now our whole term acted upon by the Laplacian, and then we add plus, this should be minus since our potential is a negative, so we have minus e squared 4 pi epsilon naught 1 over r times our wave function psi equals e psi. Okay, so now we can move this, we can combine these terms into one psi. So if I erase this term, this can be written as minus e square over 4 pi epsilon naught plus E, or the total energy, times psi equals 0.